everyone, how are we doing? We got everything going good. Had to do some setup, did a little more with the lighting, so we got a little bit of like red and blue lights. You never know. We'll see if people join the chat, but we're probably going to start here with some data analytics. So get ready for data analytics number 4 or 5, something like that. 4 or 5 data analytics. We're doing data analytics coming up here. So how's everyone doing? A little chill music right here. I can't hear it because I didn't charge the what are they called? The earbuds? Something like that. Didn't get them charged, so I can't hear the music. Only you can hear the music. So we are logging into Canvas as we're getting going right here. If you're in the chat, feel free to say hi. We're gonna make sure we have the notes so people can follow along later. We're gonna look at doing data analytics to start. A few people have been asking about that and say, how do we do the data analytics? How do we do it? How do we do it? Logging into Canvas. Canvas. Okay, get Microsoft Word up and going. Get Jump up and going. Got good stuff from yesterday. Good stuff. And Stat 201. A few people have done it, it looks like. Analytics number 4? Number 4? That's crazy. Wow. Really? Wow. See, have 2 things due on Thursday. 2 things due on Thursday. I tell people to hang out after class on Thursday. I have assignments due, a lot of stuff. I wanted to do probability yesterday, but then I thought it'd be better to review. So let's get data analytics regression going right here. Maybe put it to a Friday. I think people won't notice it. Thursday's a big day. Thursday's a big day. Tomorrow. Hey, Savannah, good to see you here. We're about to do data analytics. Do you have any other questions? Let me know what you're doing. Thursday's a big day. We're probably going to do some of the questions. Chapter 12 quiz, yeah. We'll start doing that in class too. I have a job review in a second, but for the data analytics assignment, is there a video? Yep. The visualization playlist, chapter 12 quiz. You bet. Well, you know what? Would people want to do? We can do chapter 12 quiz right away. Would you want to do that instead since you're here? I do have a video. I'm gonna maybe do data analytics today too. Oh, MuBot's not awake. MuBot's not awake. What do you want to do on chapter 12 quiz? So we are doing it during class, and we're basically running in tandem with the material right now. I need to look at the schedule. I moved everything back, and then just with spring break, it's like everyone forgets everything, and I'm like, I don't know if people remember anything from sampling. So we kind of did a review, and then we did like a quick preview of probability. There is the video going over the regression. It doesn't have everything. Question of 1A consumer over 1 year period, 15% of cars, I believe it is, for the data analytics. Yep, MuBot's got a poster right here. The visualization playlist has all the visualization walkthroughs and how to do them in there. So watching those videos right there. The American Red Cross says about 44.8% of people have a certain blood type. Yep. These are some of my favorite questions and really go over how to do these questions. You bet, Elizabeth. I am low-key confused. Yeah, no worries, Skylar. And check out the playlist right there. It has links to it. You can always go to the visualization playlist. It has most of what you need to do. And definitely watching the lecture again. We go over how to make the residual plot in the lecture. We go over how to talk about the R-squared, the intercept, the slope, the significance of the slope. Good stuff. Savannah's got a lot of good questions today. I like it. So here we go. Let's go check it out. We got some good questions already. Chapter 12 quiz, going to be a tough one. This is probably one of my favorite chapters, as I keep saying, because it's very mathy. If you know how to do this chapter, you know how to do it. If you don't know how to do this chapter, you don't know how to do it. So we're going to jump into this chapter, start working on some of the hardest problems, and take a look at it. So let's check it out. A certain bowler. Here we got the first question here from Savannah. Consumer organization estimates. So let's go find that here on the main screen. There's 2 consumer organizations estimate. And so while you do these problems, here's the first one. I about know where these are at. Oh, I'm still zoomed in from yesterday. So as you do these problems, you have to know what you're solving for. You have to understand the conditions. You have to understand the steps to solve it. So what I ask you to do, and let me mark this in the notes. So as you work these problems, Stat 201, MyPearson quiz 12, and this is a consumer organization estimates. As you work these problems, notation is key. So you need to be able to mark your what while doing this. So people tell me in the chat, while doing this,
Notation,
what do you need to mark while doing these questions? While doing any of these questions, if you do this on the test, have your scratch sheet of paper next to you, and this is how to do these. Do them by marking your what? Savannah knows right there for 100 points, notation. That is going to be the #1 way to do these. So what we want to do is we're going to start by using what we learned in the chapter and use that knowledge to our advantage. We see 17% of cars need to be repaired once. 9% of cars need to be repaired twice, and 4% of cars will be repaired 3 or more times. Now, what you get right here is a table of probabilities. You have as the following, the event, so we'll go E, the event of 1 repair, 2 repairs, and 3 repairs, and then the probability of the event is going to be over here. That's the probability of the event. It says 1 repair is 17% of the time. 2 repairs is 9% of the time. And 3 or more repairs are 4% of the time. Now, what rule of probability have we not fulfilled right here? There are 5 rules of probability that we mentioned in our class. The 5 rules of probability are the addition rule, the multiplication rule, the complement, set of all probabilities add to 1, and also probabilities are contained between 0 and 1. So what rule of probability looks to have a problem right here with 17%, 9%, and 4%? So what rule of probability? We're writing down all of our notation and reviewing the rules of probability. So what rule of probability is currently not fulfilled as we wrote out everything that could occur? Because we have your car either gets 1 repair, 2 repairs, or 3 or more repairs. So it's literally like you have a car, and this car will either get 1 repair, 2 repairs, or 3 or more repairs. So what rule of probability? So think through this is the key stuff. Not quite multiplication, good. So it might go that route for answering the questions. But with the information we currently have, Savannah, more points right there. Think about this, we're trying to write the full table of what could occur. The probability of the set of everything that could occur is equal to 1. So not the subtraction, so there's no subtraction rule, there's the multiplication, addition, complement, which is kind of subtraction, kind of the subtraction rule. Multiplication, addition, complement, set of all probabilities add up to 1, and probabilities are contained between 0 and 1. These probabilities are between 0 and 1, so they satisfy that. Multiplication and addition are just how we do 2 events occurring at the same time, or one or the other event occurring, with multiplication first or addition to do one or the other event occurring. So the issue we have right here, and I'm going to show another table, is we do not have the set of all probabilities add up to 1. Let me find that graphic really quick that we made yesterday. We made a really good graphic in class. Here it is right here. So yesterday in class, we drew out this. If you don't have this information, we actually showed how it relates to the test. So we'll use some of this today over here with the rule. There's 3 rules on here. So what rule does our table currently violate? It doesn't violate the addition or the multiplication or the complement. So Savannah, what rule have we narrowed it down to this having a problem with the probabilities we wrote out? Those probabilities do not currently add up to what? These probabilities right here, the set of probabilities we've written do not currently add up to what? Which is a rule of probability. Like if you write out everything that could occur, they have to add up to 1. Savannah, great job right there. So what we're missing, and they don't tell you, is what if a car gets 0 repairs? Great job, Elizabeth, too. So if a car gets 0 repairs, now we would do, how would we find this? And actually, you're going to use another rule of probability. You're going to use the addition rule, and then you're going to take, so you're actually finding, to find the probability of 0, it's your car not getting repairs. Does that make sense? The probability of 0 repairs. Good to see you there, George. Yeah, of course. Anytime, swing by. So to find the probability of 0 repairs, we're going to use the addition rule right here. So the addition rule says we can add together things that are disjoint, i.e. don't happen at the same time, like your car can't get 1 repairs and get 2 repairs. And then we're going to subtract it out of the total. So all you're doing is just finding what is the probability not contained in this table, because we are missing one thing right here. So 0, and we're just adding these up. Does this make sense to people? Like these steps I'm doing, and so it's gonna be 70%, because that's 1 minus that is 70%. Oops. How are we doing on the theory of this? We just found the complement, because 1 minus the others, we just did that, and this equaled to 30%. So that equals to 70%. The probability of 0 repairs, because this we just substitute E for a number right here, probability of 0 repairs. Is this all making theoretical sense? The point is to connect the topics and to understand that we use the complement right here by adding together things with the addition rule. And we just found the first answer. The probability your car needs 0 repairs is that. That's the first answer right there found. The probability that your car will require no more than 1 repair. So no more than 1 repair would mean how many repairs? No more than 1 repair. What would it mean? Talk to me in words. No more than 1 repair. If you say my car did not need more than 1 repair, it could have had blank or blank repairs. If your car needed no more than 1 repairs, your car could have had blank or blank repairs. If it needed no more than 1 repair, it could have had blank or blank repairs. If it needed no more than 1 repairs. Don't worry about being wrong, we get points for anything. If it needed no more than 1 repair. You have to be like, no more than 1. If I say, don't eat more than 1 steak, you say, well, I had 0 steaks. Okay, you didn't eat more than 1. Don't eat more than 1 steak. I had 1 steak. Okay, you had no more than 1. So the answer is, it could be, no, it's the probability of 0 or 1 repair. The probability of 0 or 1 repair. Remember, we're just putting the number in where E is at because E is the event. So it's the probability of 0 or 1 repair. Now we have to know if it's disjoint, right? And then remember, you get this on the test. Oh, great job, Elizabeth. Already got the answer in the chat. Nice job, Elizabeth. Points right there. Because these are disjoint, they can be added together. So Elizabeth, you are correct. We literally just add these together because during a given year, your car can't get 0 and also 1 repair at the same time. Like your car either gets 0 repairs or it gets 1 repairs. It can't be the case that your car got 0 repairs and also the case that your car got 1 repair. That is the terminology we call disjoint, i.e. mutually exclusive, which is the rule to add things together. You have to satisfy this condition right here that they are disjoint slash, or it means the same thing to say mutually exclusive. So make sure you meet this condition before adding things together. And notice I use the or word right here to say either you get 0 or 1 repairs. The probability that the car will have some repairs, and actually this is really easy. So who's got this? We kind of already figured it out. Because either your car gets no repairs or your car gets some repairs. So you can say like, well, it's basically the probability of my car not getting repairs. You can say it that way, as everything not getting repairs. So, but we also figured it out a moment ago. Like some repairs means it could get 1, 2, or 3. Yep, Elizabeth, that's the one we'll do next right here. There's a second version of this one that uses the multiplication rule. We'll do that one next. Yep, we'll do that one next right here. So, and Elizabeth, great work working along right here. We'll do the second version. I've already got it marked here on, like, just so you know. Not quite Elizabeth for this one. Oh, you might have, or you might have a different one. So this one right here says your car gets some repairs. So your car could get 1 repair, 2 repair, or 3+ repairs. Notice how we're saying or. This is the key when you talk this out. There's a lot of ways to solve this one, but one way is to say, well, maybe I could get 1 repair, or 2 repairs, or 3 repairs. And notice how we've actually just written a math equation right here, and all we do now is plug in the numbers. So all we're going to do here is say, well, we either get 1 repair, 2 repairs, or 3 repairs. Since these things cannot occur at the same time, they are mutually exclusive, and that means we can add them together. So we also found this to begin because we found the probability of no repairs. And you can say either my car gets no repairs, 70% probability, or my car gets some repairs. So what is the probability here? And so remember, keep reviewing the rules. This is currently the addition rule we are using that says things can be easily added together when they are disjoint, meaning they can't happen at the same time. Have clear definitions and look over your formula sheet when doing these problems. So the probability is right there. And so that's got it 70, 87, 30. And then we'll do the next version right here. 70, I love these problems because if you do the math right, you always get them right. I was waiting to get it wrong. So great job, Savannah right there. Let's do the next version, which is a little tougher. So what are we gonna do first? You know it, you love it. Tell me in the chat, get more points. What are we gonna do first? You gotta train your brain to do this. You gotta say, I don't need to do this. I'm not gonna write things down. No.
Notation,
Leo,
brother.
I saw Leo on campus and he still knows about notation, brother. So we're gonna write down our notation to start. It's gonna be very similar for this question with a table that we're gonna make here listing the probabilities. And so P just stands for the probability. It might be for yours, it might not be for mine. Mine was 70. My sixes sometimes looks like zeros. We found 70 by adding together the repairs and subtracting it out of 1. So you had to make the table equal to 1, and this one will have a similar issue with it. So you'll see that right here for this problem. This is the one you're working on, I think. So there's 2 versions. This one does a lot more multiplication rule. So for this right here, we write out, you can put event right here. I think usually people put the event there and then the probability of the event. Like you can literally just say like event drink coffee. So if this is a table for Brian and I put probability of the event, so that's probability event already. And then I put the probability over here. What am I telling you about myself every morning? And then just to review, what do you think this table is currently telling you about Brian most mornings? Just understanding what this table means. We're just trying to understand, what am I writing out here? What does this mean? We've got the event drink coffee with probability of event 99% for a morning. We've got the event oatmeal with probability of the event 80%. What does that mean? We'll do salesperson. Yeah, oh, that's one of my favorite ones. What does this table mean? What am I writing? What is this notation? Any thoughts on it? We have to know what we're writing out so that way we can use it to solve all the problems, and then they just start to speed up as you get the practice on solving them. What is drink coffee? PE. So E is just a substitute for like the event. Yes. And so these are just probabilities of certain things occurring each morning. So can I say, could I do this right here? The probability of drink coffee plus the probability of oatmeal and find this out. Can I do this? I want you to think through this really quickly, and then we're going to finish this problem right here. But can I do this? So I've abbreviated oatmeal as O right there. I can call it oat maybe, make it more obvious. But can I do this? Can I do the probability Brian drinks coffee or eats oatmeal and easily add those up? You should see a clear problem with this, and it breaks a rule of probability. So I'm kind of, correct. And not because it doesn't equal 1, it's actually because it exceeds 1, showing that there's overlap. Because think about this, during a given morning, Brian could drink coffee and eat oatmeal. That's what it means for things to be not disjoint. Not disjoint means one could occur and the other could occur. This means not disjoint. It doesn't mean they have to both occur, but you could drink coffee and you could eat oatmeal. This table is a bunch of disjoint things because we're talking about our car getting repairs and how many repairs it got. So now we have actually 2 cars, but we'll talk about the 2 cars getting repairs and the probability of 1 repair, 2 repairs, 3 plus repairs, and 0 repairs. Probability of 1 repair, and these are listed up above for you, is 15%. And please tell me if I make an error. Probability of 6% for 2 repairs, and 3 or more repairs is 4%. So we are going to find the 0 repairs by using the complement rule by subtracting all of these from 1. So rather 1 minus, so we should put the 1 minus on the other side. So that probability right there is the complement of these, which that looks to be 25%. So since these add up to 25%, what is the new probability? So the probability of 0 repairs is what percent? It didn't even ask us this. We're just writing our information to start so that we can use it to solve the problem. This is trying to be tricky by not giving you the 0 repairs. So these add up to 75% via the addition rule, which we can add together disjoint events because your car can't get 1 and 2 repairs in the same year. If you got 2 repairs, you got 2. If you got 1, you got 1. And since they add up to 25%, the complement of 25% is what? Complement means 1 minus. So the complement of 25%, I actually wrote the answer by accident. The complement of 25% is 75%. So if your car doesn't get 1, 2, or 3 plus repairs, it gets 0 repairs, and the probability of that is 75% via 1 minus the other ones. So you have 2 cars. Now, the best way this problem would be worked is to say you have a car and your friend in another city has a car. So here's what you need to solve. Your car did not need a repair. Your car got 0 repairs, and your friend's car got 0 repairs. When I say and your friend's car got 0 repairs, and tells us we're using the what rule. These are the things to remember and to practice. By saying and great job, Savannah, right there. By saying and, we're using the what rule. So when I say your car did not get repairs, Savannah, good practice. We're going to throw you big points for that. It's not the addition rule, though. And is going to be the multiplication rule. So when we say your car did not get repairs and your friend's car did not get repairs, and great job, Elizabeth, right there, and really good practice, everyone. Don't worry, just keep practicing. And is going to be the multiplication rule, and they need to be independent. So that's why I changed the question to say it's your friend's car across the city, because then it wouldn't matter, Rock knows, it wouldn't matter if your car got repairs. That has nothing to do with your friend's car getting repairs. So all we do is substitute into this probability of not repair and probability of not repair. Notice when I wrote the multiplication, I wrote and right there, and you do get those notes that we just showed on the test. So if you're confused and you forget the rules, 3 of them are on the test. And there's the probability right there, 0.75 times 0.75. The probability of not repair and not repair is the probability of both cars not getting repaired. So this first one right there is the answer. Now for the next one, it says they both will need repairs. Now be careful. What is the probability of getting repairs? So we need repairs. So repair and repair. What is the probability of needing repairs? Be careful. This is the tough part of this problem. Because what is the probability your car would need repairs? You saw, I'll answer it in a moment, but take a shot at it. Because either your car doesn't need repairs or it does need repairs. And your first car needs repairs and your second car needs repairs. What's the probability of needing repairs? Because either your car doesn't need repairs or it does need repairs. What's the probability of needing repairs? Great job, Elizabeth. That's it. You got it. It is 0.25, and you just put 0.25. The first car needed repairs and the second car needed repairs, which is 1/16, which is 0.0625, I believe. So right here, 0.0625. There we go. And that's the answer to this one. The first car needed repairs and the second car needed repairs. Now this one gets a little tricky, and there's really a lot of ways to solve it. It says at least one of your cars needs repairs. So if you think about this, we could write out another table here of your cars. And we would have the instances of these are the events, and this is the probability of the events. And at least one of your cars needing repairs. And I'm going to color code this in a second. The green means your car is good. And the orange means it needs repairs. So there's the event where both your cars did not need repairs. The event, really? Just draw the arrow and move it. The event where one of your cars, the first car, needed repairs, and the event where the second car needed repairs, and the event where both cars needed repairs. But here's the thing. We're interested in this right here. Didn't we already figure out in the first problem the probability that they both don't need repairs? The first car did not need repairs, and the second car did not need repairs. So what could we do since we figured this probability out in the first problem? Does anyone know what we could do to solve this out? Does anyone know what we could do to solve this out? Because either neither of your cars need repairs or at least one of them need repairs. Well, that's going to be, so that's for one car. That's for one car, Elizabeth. So that is the probability one car needs repairs. Because now we have the probability that exactly, Elizabeth, this is the complement of, so it's both, what is the complement of both cars not needing repairs? Because either it's the case that both cars do not need repairs or at least one car needs repairs. And that's the math right there. And this will solve out to, this is the full probability for all this, the whole thing right here. We didn't do each individual one. We did the full everything here. And that'd be 4, 3, 7, 5. And it's a cheat, but it's always the complement of the first one. As long as I did the math right in my head, we're good. Looks right. We're good. So this one and this one are always complements. That's a little cheat for this problem, but and you should understand why. Like the theory of this is what matters. I love this problem. It's really great. Yeah, it's really good problem. Practice on it. I love it. The next question, I think Savannah might have the next one too, is at the center for, we're going to keep going through the questions. 2015 study for National Health Center. So let's go find that one. This is like my favorite chapter. I almost find it relaxing to just do these. I'll start. Oh, there's the 5-pack. A bowler. There it is. There's the Red Cross. There's the M&M one. Is this a study, a 2015? No, we're looking for a 2015 study. 2015 study. Nervous kicker. Some of these are really quick. I don't like those ones. Here we go. 2015 study. Here we go. 2015 study. No? What did we do? No. Did I do something wrong? 2015 study. Okay, let's do this. And thank you both. You both are rock stars. Like, you're here quite often, and I greatly appreciate it. And you answer a ton of questions. It means a lot to me because the only way to remember these things is to like type it out or try to think it or say it or write it down. Because it can just, if you don't do it, it's like just watching someone play piano. I always use that analogy. It's like you can watch someone play piano, you won't learn a lot until you sit down, and then you sit down and play the piano. You're like, oh, this is actually more difficult. I gotta hit this key next, and so you get to practice from it. Okay, so once again, we're gonna start by writing down the probabilities. That's always gonna be. Leo knows the answers. Oh, the whole screen froze there. That's fine. Thank you, Leo. Okay, let's write down our probabilities and do this problem right here. Okay, a center. Can we do the version that doesn't have? Yeah. Do you want it? We'll do this one real quick here. You know what, Savannah? Since you've asked, I'm going to do this one super quick on my own, so it's in the video, and other people can watch it later, and then we'll do that one next. So I won't ask as many questions because you're here. I don't want to optimize your time. I'm just going to wreck this one. You ready? Here's how we do. We're going to speed run it a little bit here. So if you think I went too quick, swing by in the future and ask any questions. Okay, a survey for the National Health Center found that 71% of adults have a cell phone and had no landline. I'm just going to call this probability of the event, and the event is having a cell phone. So the event, cell phone, I'm just going to call it cell phone. You can do that in no cell. I hate that they like double up on it, is 0.71 and then 0.29. So this raises concerns, sure, whatever. What is the probability that all of these adults have only a cell phone? So, but only, okay. So how many adults did they talk to? How many people did they reach out to? What is probably that, how many groups was it? Select 8, there it is, select 8. Okay, so it would be that the first, I'm blocking the numbers. It'd be probability that they all have a cell phone, and it would be, it'd be 8. Thank you so much. I couldn't find it in the question. And so it's probability of cell phone and probability of cell phone and cell phone and cell phone and cell phone and cell phone. 1, 2, 3, 4, 5, 6, 7, 8. I'm just abbreviating it C right now for probability of cell phone, which is 0.71 to the 8th power, because you're just multiplying it by itself that many times. 0.71, 2, 3, 4, 5, 6, 7, 8. And there's the answer to the first one. The probability of first has a cell phone, the second has a cell phone, the third, the fourth, the fifth, the sixth. 1, 2, 3, 4, 5, and round up. There we go. Off topic, but is a predictor variable? Thank you so much, Savannah, helping out right there. Yep, we're predicting price is being predicted, correct? For the data analytics, price is being predicted. What is probably that none of these adults have a cell phone? So it'd be kind of the same, but it's like the first doesn't. So it'd be not cell phone, not cell phone, not cell phone. It's the same thing, but you're now saying the probability the first doesn't have it, the second doesn't have it, the third, the fourth, the fifth, all the way up here to the 8th. So now we take the not cell phone probability of 0.29 and go 2, 3, 4, 5, 6, 7, 8. It's basically 0. Oh gosh. 1, 2, 3, 4, 5, and yeah, that's the fifth digit. Very close to 0. What's the probability that at least one of these adults has only a cell phone? So that would be the complement of this last one, because either none of them have it or at least one has it. So we should be able to go, and as long as I didn't go too quick, we got it. There we go. And the reason for the last one, just once again doing it quickly here so we can get to the next question, is because either nobody has a cell phone, which is the probability of that tiny one right there, or at least one has a cell phone, because it's like, well, what's the complement of no one having a cell phone? At least one person has a cell phone. It's not everyone has a cell phone, because either no one has a cell phone or at least one person has a cell phone. I remove the landline portion because it's just extra nonsense info. Let's go find that other 2015. Ah, here we go. This is the one, right, Savannah? Give me a yes or no in the chat as I copy paste this. Is this the one you're asking about? Looks similar. So is this the one right here? It might be a totally different 2015 one. If so, I won't do it. Okay, this is the one. Okay, let's do it. Okay, help me out with this one now. So the first thing we do is we mark our what? Tell me in the chat. You know what we're going to do.
Notation, brother.
Right there. Tell me what we're doing, and I'm going to start doing it. But it has 8. Then you'll just substitute 8 in wherever I do 5 in this one. Mine deals with 5 households, and yours will just, really, got the green mark. Great job, Savannah, right there. You will substitute in 8. I will use 5, and it randomly generates as we do it. So we mark our notation right here. And we have the event and the probability of the event. And the event had no landline service. So, okay, so this one says no landline. So we're going to say event, no landline, and then we have the event landline. So the probability of no landline is 51%. The probability of landline is 49%. Does that make sense? And my 4s and 9s look very similar. But the probability of landline is the complement of no landline. So either have a landline or you don't have a landline. That means a phone you pick up right there. What is the probability that all 5 of them have a landline? So what would you say right here? The first has a landline, and the second has a landline, and the third has a landline. How would we solve that, Savannah? So now that we've got it written out, we can just think, okay, well, each house is probably independent of each other, because it's not going to be like, oh, you have a landline, I'm getting one, even though service in an area might be dependent. But we will assume, since it's asking us to do this, and it has a blank for us to put in a number, that we can do it due to independence. So basically, by me saying independent, I'm saying we're going to what things together. Now, so Savannah, so tell me what that solves to. And I like that you said that, Savannah, because I want you to see what that solves to, and I want you to think, like, wait a minute here. So a lot of people do that. But I want you to see what that solves to, and I want you to be like, wait a minute. So what does that solve to? And then be like, wait a minute, this is the catch on the test. If you accidentally do this, you're like, wait a minute. Because there's a rule of probability. Now you're on the right track-ish. Yeah, it's too big, right? If you times it by 8, it escapes 1, which there's a rule that says probabilities contained between 0 and 1. So what we actually do is we multiply the probability of the events together. So we have probability of event times probability of event times probability of event. We do this 8 times. So by multiplying something together 8 times, what happens? By multiplying, that's a big E right there, E. By multiplying something together into itself 8 times, what happens to it? Or what could we reduce it to? So it's first has a landline, and second has a landline, and third has a landline, and fourth and fifth have a landline. So you're actually doing, does that make sense, Savannah, right there? You're actually doing 0.49 to the 5th power, which is 0.49 times 0.49 times 0.49 times 0.49. It's getting smaller and smaller and smaller as you do this. So this is the multiplication rule right here, where we say the first has a landline, and the second has a landline, and the third, and the fourth, and the fifth have a landline, and that's got it right there. So that is how to do this one, using the multiplication rule, round to 5 decimals, 1, 2, 3, 4, 5, round up, because of 7, and that is 5 decimals. The next is, what is probability that at least one does not have a landline? So we have to think about the way this looks. At least, or let me do it the way I think this helps people. This is the #1 way to do it, is to write a sentence. It'll be the case that either at least one has a landline or what? So finish this sentence. It'll be the case that at least one has a landline or what? This is the way to solve these. A lot of people solve these correctly using this tactic. Write the sentence when you have an at least one problem. So either at least one house will have a landline, but we're close, Savannah. Not that at least or one doesn't. So think about this. If I tell you, I'm going to give you 4 packs of candy, and at least one will have a prize in it, or what? That's right there. That's at least one having a prize. That's a prize right there. Either at least one will have a prize. There's at least one having 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 a prize, or what? At least one will have a landline, or what? Now we're actually seeing it, because what's the scenario? This is the tough part, and these are the toughest questions on the test. At least one has a landline, or what? At least one has a landline, or what? So how about this? If you have siblings, you have at least one brother. So wait, if you have siblings, so think of this one. You either have, like, I have at least one brother. Not 3 don't. Good job, people practicing right here. If you have siblings, you have at least one brother, or you have what? If you have siblings, you have at least one brother, or what? I think you might get it with that. Think about everything else that could occur. Either you have at least one brother, so you could have 2 brothers, 3 brothers, 4 brothers, 5 brothers, or 1 brother. You have at least one brother, or you have what brothers? I think this will make sense now. Well, not no sisters, because you either have at least one brother, or you don't have any brothers. Does that make sense? You would have only, yes, correct. You're on the right track there. So you'd either have at least one brother, or you'd have no brothers. So at least one house, this is the tough part. So think about this. If you are trying to find someone with a landline, and you go to your 2 neighbors, it could be that both your neighbors have landlines. Does that make sense? Tell me if you're following this. It could be that both your neighbors have landlines. Does that make sense? Like, you go and you talk to your neighbor, like, oh, I have a landline. The other neighbor's like, I have a landline too. I've got a phone. Does that make sense? Does this make sense right there? Because right now, at least one has a landline. So both your neighbors have landlines. How about if one of your neighbor has a landline? Is there at least one landline? Good to see you, Elizabeth. If your left neighbor right here has a landline, this is yes, they have a landline. This is no, they don't. Does at least one person have a landline? Does at least one person have a landline there? The orange means landline, that they have one. Yes. How about in this scenario? Does at least one person have a landline here? We're almost done, because this will hopefully make sense right here with this. Does at least one person have a landline? Right there, where your neighbor on the right has a landline. Does at least one, I'm not trying to trick you, does at least one have a landline? Like, do you have at least one neighbor with a landline? Yes. So how about this? Both your neighbors don't have landlines. Does at least one have a landline there? No. So either at least one of your neighbors has a landline, or what of your neighbors have landlines? So either at least one of your neighbors has a landline, or what of your neighbors have landlines? At least one house has a landline, or what houses have landlines? You might be saying it actually as the answer. Or none. Exactly. It's like to say, I'm going to buy lottery tickets, and either at least one of these tickets will be winners, or none of them will be winners. Does that make sense? Like, if I'm holding lottery tickets right here, like, at least one of these will be a winner, or none of them will be winners. That's everything that could occur. So this is the sentence we need to solve this, that either at least one house has a landline, or none have landlines. Now, we are trying to find the probability that at least one has a landline. So this is the probability of interest right here. Now, by saying or, we can convert that to addition. Does that make sense? We're going to convert the or to addition. And what we've actually written here is the complement, because this is everything that could occur. Either at least one has a landline, or none has landlines. And guess what we use to solve this now? We're just going to use algebra. So all we do right here is we do 1 minus none have landlines equals at least one has a landline. And there's the answer. We just have to solve for none have landlines. So what is the probability none have landlines? It's going to be 0.51 raised to the 5th power, because that's the probability none have landlines. Is this making sense, Savannah? This is the tough part of this problem, where people just look at the tough problem, they go, I don't know how to solve this. But this is the tried and true way I usually get people to solve it, that they can write the sentence and solve the probabilities, they can get it. So this is the answer from this equation, and it will then solve to the right side of the equation to give the answer. So 0.512345, 1 minus. So there's the answer. Tell me, Savannah, if you're stuck on this. This one usually is where people say, aye. So you have to write the sentence. It would be if it says 9 houses, correct. It would be if it says 9 houses. If it says 9 houses, yes. What no on expand. Watch me get it wrong too. Very easy to mistake a probability on these, or just put in a wrong number. There's that. 1, 2, 3, 4, 5. That all rounds up. And then what is the probability at least one of them does have a landline? So either, oh, wait a minute, does not have a landline. Did I do the right one? Let me look at my equation. It might be, you have to be very careful. Let me make sure I didn't mess this up though. At least one, okay. So we're trying to find the probability that at least one has a landline. Oh, it does not. Oh my gosh. Okay. Okay, wait. The one we just found is the lower one, because it says, was the probability at least one of them does not have a landline? So it would be either they all have landlines or what? Either they all have landlines. The probability we just found, if you're solving along with us and you took the upper probability in your list right here, then we just solved the last problem, because we did either none have landlines or at least one have a landline. And now the other sentence to write, so this is the one that we're actually solving. Maybe that's where the confusion was at. So we want to find the probability at least one does not have a landline. So either at least one does not have a landline or what? So you've got a bunch of houses here. And it's either the case that at least one does not have a landline or what? The tough part of these, it's either the case that at least one does not have a landline or what? It is going to be that, Savannah. That is correct. That is correct. So what's 0.49? And what's 0.49 to the 5th power? That is correct. Good job, Savannah, right there. So it's either going to be the case that at least one does not have a landline or what? So Savannah's got it. Or what? So what is the complement of at least one doesn't have a landline? Or they would what? All what? Might be that right there. So either at least one does not have a landline or they would all. So either at least one of my tickets will not win or what? So I've got 4 tickets in my hand. At least one is not a winner or they are all what? So it's either the case that at least one is not a winner. They could all be losers with at least one not being a winner. Or they could all be wutters. So it's with 4 tickets in my hand, it is the case that either at least one is not a winner or what? Well, so at least one is not a winner or what? So finish that sentence. At least one is not a winner or what? At least one is not a winner or what? Like, these sentences are the key to solving these. Not that 3 are, all are. Good, Savannah, good job right there. So it's either the case that at least one is not a winner or they're all winners. Because either they're all winners or at least one's not a winner. Does that make sense? This is the tough part. And Elizabeth, great job right there. Either at least one's not a winner or, okay, think about this. Like, if you have kids right here, it's like either at least one of your kids gets sick or what? Finish this sentence. If you have kids and you're like, the flu's going around or something, either at least one of your kids gets the flu or what if your kids get flu? Either at least one of my kids is going to get the flu, my bunnies, no, my bunnies, no. At least one of my bunnies is going to get bunny flus, or one of my bunnies are going to get bunny flu. So there's another way. We're just practicing this language to talk about. Not all of them, not all of them. Either at least one or what? Close. It would be at least one bunny gets sick or what? Not all of them. At least one bunny gets sick or what of them gets sick? So either at least, I'm sorry, bunnies. Either at least one of my bunnies will get sick or what? He's gonna be so mad if a bunny gets sick now. He won't be mad. None of them. That's the complement of at least one gets sick. Either at least one of my bunnies will get sick or none of them will get sick. Since you are using, so this one right here, and we'll double check the math because I could have made an error. It's very easy to flip these. Let's look. So this one says at least one of them does not have a landline. So this would be the complement of at least one does not have a landline is all have landlines. So to do all have landlines, all of them having landlines is going to be 0.49 raised to the 5th power. And so it's then going to solve out to 1 minus this. And it's going to be 1 minus 0.49. So we'll write all have landlines equals at least one does not. And that is 1 minus 0.49 to the 5th power equals to whatever it equals. Does that make sense? Is it making sense, Savannah? These are tough questions and people just sometimes guess at them on the test. The formula remains consistent that, 2, 3, 4, 5. And it's we write them a lot more clear than MyPearson does a lot of times. And hopefully I didn't mix up the probabilities. 2, 3, 4, 5. And we feel really bad. And then the rounding, that's got it right there. Okay, moment of truth. Yeah, I got it. Good. I was getting afraid I mixed them up too. I mixed it up the first time because it's all like not this, not that. Very confusing. But good stuff. Here we'll do another one. These are tougher problems. I'm going to do the soda one next. I know you mentioned it. It's probably one of my favorite ones. I think it's a little bit easier to understand. Here's the soda one. Not that I've done this one a lot. I know exactly where it's at. One of my favorite problems to do right here, the soda promotion, because it really works well on this practicing of the not. It's just one problem on it. So you can really focus in on doing the complement. Okay, so I'm putting the notes in the thing. For a sales. Okay. So with the soda promotion one right here, let's take a look at it. And the first thing we're going to do is we're going to mark our notation. I can't state this enough that you have to get in the practice of whenever you get a probability problem, mark down your probabilities. First thing you want to do is write down the event, which will be winning cap. And the other thing that could occur is losing cap. And the probability of these things occurring, we're just going to put next to it over here. And so we have the probability of winning is 18%, and we could even call this not winning, but it's just you don't win anything is a losing cap right there. So now we've got everything written out that could occur. This is the set of all events. Probability of the set of all events is equal to 1. Probabilities are contained between 0 and 1. We actually did rule 1 and 2 of probability right here. Make sure to know your rules. So the probability of winning something when you buy a 6-pack. Well, here's the sodas in a 6-pack. And if this is win, and this is lose. Tell me what happened. Did Brian win something, yes or no? I'm color coding it so you can see. Did Brian win something, yes or no? Color coding it so you can see. Did Brian win something, yes or no? What do you think? Did I win something? I did, you're right. How about this right here? 2 more things on this and then we'll get to the answer. How about this right here? Did I win? Yes, Elizabeth, exactly. Did I win something here? Good points right there. And how good is this? How do I feel about this? I mean, this is so improbable, but we'll see that in a moment. Well, we'll do it the other way. Did I win something here? I open my first. Oh my gosh, it's an amazing day. But you know what could happen? What could happen is I could throw away that soda, apparently. What could happen is this. And let's think about this. Because either it is the case that Brian will win something, or he will what? It is either the case that Brian will win something, or what? It is either the case that Brian will win something, or what? It is either the case I'll win something from opening these 6 sodas. I'm going to open all of them. Either I'll win something or what? I don't win anything. So not winning anything would mean they're all whats. So not win anything. So not winning anything would mean all the sodas were whatters. You're getting it now. This is really good because you're on track with exactly where we're going with this, and we're just 2 steps away from solving it. They're all losers. So that's what not winning anything means, is they're all losers. Well, and this is everything that could occur. Remember when we say or? Well, these are complements because you can't win something and not win anything. So we can add together complements because they are disjoint. You can't have them both occur. That's what disjoint means, and complements are disjoint because you can't win something and not win anything. So we have right here this, and the probability of not winning anything. All we have to do is find that, and we will know the answer to the question. So Savannah, we're just going to do it, and you got this right here. Elizabeth, if you want to do it too. We're so close because all we have to do is solve this equation now. All we have to do is find the probability of not winning anything, and we will find the probability of win something. Because 1 minus not win anything. So how are we going to do that? We just did the same problem, but we did it like 10 times faster now. So your first is a loser, and your second is a loser, and your third is a loser, and your fourth is a loser, and your fifth is a loser, and your sixth is a loser. What are we doing right here? Your first is a loser, and your second is a loser, and your third is a loser, and your fourth is a loser, and your fifth is a loser, because each soda can doesn't care about the previous one. So what do we need to do? Well, it's not 0.18. Well, it says 1 minus not win anything. We have to find the probability of not winning anything, which is right here. Oh, you're on the right track. Because you have to say my first was a loser, and my second was a loser, and my third was a loser, and my fourth was a loser, and my fifth was a loser, and my sixth was a loser. So when you write it out, you say my first was a loser, and my second was a loser, and my third was a loser, and my... You see how we say and? I opened my third can, and it was a loser, and I opened my fourth can, and it was a loser, and I opened my fifth can, and it was a loser, and I opened my sixth can, and it was a loser. Because these are all the multiplication right here. It might be, I think it's gonna be smaller than that. It might be, it's gonna be smaller than that, I think. Oh, because you did the 1 minus, I think, already. Okay. Yes, that is probably correct if you did the 1 minus, because this is the probability here, which then we're gonna put it into here. Like this is the probability we're solving for right there. So the first is a loser, and the second, and the third, and the fourth, and the fifth, and the sixth. And then we go right here, and we do 1 minus, and there's the probability right there. That's got it, Savannah. So this is the probability of not winning anything, and 1 minus not winning anything is winning something. And we just solved it. So I just want to point out how much quicker this one was with writing it out. 3 decimal places. This is going to round, does it just round to 70%? I just round to that. I round it too crazily. Yeah, come on, really? Okay. That would have been nice. What was the equation? The equation right here, you have to find out the probability of not winning anything. The probability of not winning anything is they're all losers. So all losers is 0.82 to the 6th power. So when you substitute in the math right here, thank you, Elizabeth, for asking right there, you get 1 minus 0.82. Oh my gosh. 1 minus 0.82 to the 6th power equals to 0.70-ish. 0.70-ish, basically. I rounded it too harsh right there. MyPearson got mad at me. Savannah and Elizabeth, is this making more sense now? Really, these questions come down to practice. They come down to practice, and then just trying to talk about it as words. To say like, that's awesome, Savannah, yeah. And don't worry, these are tough. Like, these are the problems people get to on the test. I keep saying they're like, I have no idea how to do it. Let's do another one right here. We'll just keep rocking and rolling. And they start to make more and more sense as you keep doing them. I'll just say that. Trying to find the next one. Someone said that we haven't done yet. American Red Cross. We haven't done that one yet. A little bit longer one. Let's do it though. American Red Cross. Okay, American Red Cross problem. Thank you so much. Starting these early. American Red Cross. Oh, there's the light bulb one. It's the exact same. Light bulb one. See, watch this. We can come back to it, but you know how to do these. At least one light bulb is defective, so they all work out of 5. 2, 3, 4, 5. There you go. You know how to do them, then you know what you're looking for. I hate this one. No, I love these problems. If you know what you're looking for, then you can say it in your head like either they all work or at least one's defective. So that's what I did right there. Is I quickly went through and did that. Bowler, we'll do bowler next. Thank you, Elizabeth. So we got bowler on the docket next. Bowler. Okay, so once again, I cannot state enough that you have to write these down. You have to write down what you're looking at, and they have to know how to use the probabilities. This is a very, very, very mathy chapter. And so you have to use the math advantage. It took you 4 tries. Yeah. It's like starting a car up. It goes like, and it just goes. You're like, I get it. I know what's going on. And you really have to practice these. American Red Cross. So remember our strategies. We're going to repeat our strategies again. We got Leo helping us out.
Notation, brother.
Notation, brother. Notation, brother. I'm stepping on my cord right here. I want to hurt my microphone. Okay, so we're looking at blood types. When it comes to blood types right here, we have the event, which is just what occurs, someone's blood type, and we have the probability of that occurring. So the probability of said occurrence of whatever blood type, and we have right here type O, type A, type B, and type B. So type O has a probability of 0.454. Type A has a probability of 0.0395. Type B has a probability of they have to do all the decimals, don't they? And the rest are type AB. So we need to tell me the word for it, the what of these other ones to fill out the table. Remember the word is the third rule of probability. We need to find it's a C word, trying to help you out remembering it. And so I'll do the math then for you, but we need to find the what of these other ones because this is everyone's blood type. It's the set of everything that could occur, which is the second rule of probability. The set of everything that can occur is equal to 1. So now we could add those up with the addition rule and find the what of them. So tell me the word here. I'm looking to say, well, we need to find the what, and it's the 1 minus idea. So we need to find the what of these. So I'm going to add them up to figure out the probability of everything in the table so far. The complement, great job, Elizabeth, right there. More points in the chat. Tell me if I did the math correct, because the whole problem is contingent on this. Is that it, Savannah? Did I do the math correct? Yep, it's great job, Savannah, right there. 0.04, and that is the complement, because the probability of the set of events, which is everything that could occur, this has to equal to 1. So it's the complement right there. It's 1 minus other things. So if you're not those, like to say, if you're not these, you have to be this. Have you learned the concept yet? We did it at the very end of lecture. We did kind of a speed run-ish of it, but we'll go over it tomorrow, and I'm going to look at due dates and stuff. Make sure we're perfectly tracking for the test, but we did it kind of speed run-ish at the end of lecture. So we wrote down, check out the end of yesterday's lecture, where we wrote down the notes somewhere on here. I've opened so many Word docs that we've lost it. There we go. There it is. Here it is. First notepad right here. And then we talked about how it applies, and we did some problems right there. There it is. There's the complement. We even did a 1 minus, at least one problem. So now that we've got our table, I'm going to go ahead here and put these side by side with the problems, so we can do them in tandem. Okay. We'll see the screen here in a second. We don't need the rest of the information. We only need the table. Okay. There we go. Oh, I'm still on the screen. So what is the probability that a donor has AB? Well, we already solved that because we just did the necessary pre-work to get this started up. What is the probability that a donor has A or B? Now, why can you add those together? I want you to tell me theoretically why I can add together A or B. You can say the words, like the rule we talk about, but why can I do this? Why can I say the probability someone has A or the probability someone has B? And you should always check this before doing it. Oops, oh, and look, that is not a valid probability, so I did something wrong. Why can I add those together? Why can I do that? There's a rule with probabilities that says I can do this if two things are what? What does that mean? And why theoretically does it make sense to add them? Well, they wouldn't be AB. Good. So then you're not AB if you have A or B. This is saying, see, it's AT, good comments right there. And it is the or. Good point. This is the or, and it's not independent though. Good, everyone, good answers and lots of points in the chat. The or word says that we are doing the addition rule, and the addition rule requires that two things be disjoint. So the addition rule, and this is, remember, always look at your formula sheet because the formula sheet has it on here. The addition rule has the requirement mutually exclusive, which means someone can't have A blood and have B blood. You can't, I know I said and there, but you can't have both at the same time. You can't have A blood in your body and B blood. And if you do, that's a problem. So you naturally won't have A and B blood. Maybe there's like one person in the world, but for pretty much everybody, it's mutually exclusive. So we'll go with the idea that having A blood excludes you from having B blood. Does that make sense what exclusive is? If one occurs, the other can't occur. And with that, we can easily add together. I've got the multiplication highlighted, but you can easily add things together when they are disjoint / mutually exclusive. And that's why we're able to do this addition right there. The probability that they're not O. So how to vampire right there. Dang it, Savannah. That is true. See, wouldn't they? I guess they're not living, so they don't have that problem. But not O blood. I'll do this one. This is just the complement rule. We've already talked about the complement a good bit. So you either have O blood or you don't have O blood, and not having it is 1 minus. Once again, look at the formula sheet we wrote out, because on the formula sheet yesterday we put the word not right here. I've already got it highlighted. The last one was adding together the two probabilities, probability of A or the probability of B. So when you hear A or B, you go here and you add together A or B. So it was the addition of these two probabilities. The next one is the complement rule, because it uses the word not. So either you have O or you do not have O. So it's a minus right there. Does that make sense? And please ask all the questions as we do this. If you're here, you get to tell me how fast to go through the questions. So that's what we do. And for the next, it goes to the multiplication rule. Now we have 4 people. If 2 random people walk into the hospital, their blood types would be what? Or even 4 random people walk into the hospital or walk into Red Cross. Their blood types would be what of each other? And we'll talk about what that means. If 4 random people walk into the Red Cross, their blood types would be what of each other? Random people, not friends, not family, random people. Their blood types would be what? Random people. Not a family that comes in, not friends who come in, not a group that comes in. They have no association. They don't know each other. Independent. The exact word I was looking for right here is independent, because knowing the first person's blood type would tell you nothing about the second and third and fourth person's blood type. So we can now use the multiplication rule, which is using the and word. When we say the first person's blood type is this, and the second person's blood type is this, and the third person's blood type is this, and the fourth person. That's kind of what independent means, is random. So independent means that it doesn't tell you anything. It's random. Like if you know one person's blood type, it tells you nothing about the other person's blood type. And because we satisfy this, we can multiply the first person's blood type's probability times the second person's blood type's probability. So the probability that everyone who walks in today is blood type O. Can you get this one? I'll show how to solve it in a second. But the first person is O, and the second person is O, and the third person is O, and the fourth person is O, and that's it. So there's the written version of it. The first is O, and the second is O, and the third is O, and the fourth is O. So how would we do that? The first, because we can multiply them, because, well, I'm kind of saying it. How do we do this? The first person's O, and the second person's O, and the third person's O, and the fourth person's O, because they're independent, and we can multiply them together. So what do we get right here? So you just have to change what you've written into numbers, basically, because I've wrote it out as a sentence, like the first one's O, and the second one's O, and the third one's O, and the fourth one's O. So what will this solve to, or how do we solve it? I like to a lot of times put it right towards the problem, and then if you see it, you understand it more. What is this? What does this solve to? What is the answer? How do we do it? First was O, and the second was O, and the third was O, and the fourth was O. That's it. Great job, Elizabeth. Yep. You can do that. You're multiplying it together like 2, 3, 4, and it's just to the fourth power. Yep. It's O to the fourth power. The first was O and the second was O. Yep, and then make sure to use yours right there, 0.45 to the fourth power. Or if there's 4 or 5, how many people walk in? 3 decimal places, so there we go right there. No one is AB. Now this is where it gets more difficult. This is in at least one problem. It's either the case that no one is AB or what is AB. So either no one is AB, so it's either the case no one is AB or what? It's either the case that no one is AB or what? It's either the case that no one is AB or what? It's either the case, like everything that could occur could be. No, don't add. So when it says, yeah, to get AB right here, so AB was found by subtracting out the other remaining probabilities. That is true. When writing the table, AB is found by subtracting the probabilities. We can do bowling. Yep, Skylar, you got it. So, and I probably need to do data analytics, do an update video on it. So it's either the case no one is AB or what? It's either the case no one is AB or what? Oh, well, we don't even need to solve this. It says probably no one is AB. Well, if no one is AB, so the first person is not AB. Sorry, I was actually going the wrong way on that. Probability of not AB times probability of not AB. Might be. M&M, we can probably do that one. We might have enough time. That's a longer one. And I do have videos on it. So here is it written out. The first person was not AB, and the second person was not AB, and the third person was not AB, and the fourth person was not AB. So what does this solve to? How do we figure out the probability of not being AB? What is the probability of not being AB? We can solve that on my sheet right here, because all I have to do is find that, and then I'm good. Because I have the first person was not AB, and the second, yep. JT, I'll go ahead and solve it. JT wrote it out. JT is correct right there. So since you put the equation, I'll go ahead and do 1 minus 0.044. That's probably of not being AB. Yep, and then it's, oh, but not 1 minus it to the fourth power though, because this is the probability of not being AB, and then it's the probability of not being AB multiplied 4 times. Savannah, I did go a slightly wrong route by accident. Sorry, the lights. But it's the first person is not AB, and the second person is not AB, and the third person is not AB, and the fourth person is not AB. So we just found the probability of not being AB, which was 0.956. And we have the probability that no one is AB. Does that make sense? So it was the first was not AB, and the second was not AB, and the third was not AB, and the fourth was not AB. The probability that they are all, not all type A. So this is saying they're not all type A, and this is where we need to use the complement. Because either they are not all type A, or they are what? Either they are not all type A, or what? And the not really makes it easy. Like the way I wrote this, either they are not all type A, or they are what? I have to write my sentence here for these complement ones. Either they are not all type A, or what? So finish the sentence. This is an or right here. Either they are, and this is probably the hardest question, like if there's on, they all are, Savannah, yes, it's yes. Either they are not all type A, or they are all type A. So we're trying to solve for that first one. We algebra this over on the other side. Savannah, that's exactly it. Getting it down a little bit more. It's right in the sentence. So either they are not all type A, or they are all type A. Not all type A means like at least one person's not type A. So either they're not all type A, or they are all type A. And so we figure out the probability of all type A, which would be the first person is type A, and the second person is type A, and the third, and the fourth. How many people are there? There's 4 people, right? So it would be all type A is 0.395 to the 4th power, and that's going to solve to the probability. So you got to write the sentences. And so the first was type A, and the second, and the third, and the fourth. 1 minus is the probability they're not all type A. I feel like we have 1 wrong from misreading a problem. We're doing a decimal error. They want so many decimals. The probability that at least one person is B. At least one person is type B. So it is either the case that at least one is B or what? So this is good practice right here. At least one is B or what? At least one is B or what? And so you're on the right track here, or you might know it. All are? Well, if at least one is B, then all of them being B would be at least one is B. So if at least one person is B, none, and that's either at least one has type B blood. You're like, we need someone with type B blood. Does at least 1% have B blood? And you're like, no one has it. You're like, oh no, we're in the world where none have B blood. Does that make sense? Like, one of these things will occur when you talk to the 4 of them. Either at least one will have B blood, it could be all of them, or none of them will have B blood. So that's why we're doing the complement right here. This is everything that could occur. And everything that could occur has a probability of 1. That's why we set it equal to 1 right there. And now, whoops, no, don't do that. I don't know what I clicked. I think I clicked show answer or something. That'd have been sad. Because I think I've done everything correct. It's very easy to make mistakes on these, like decimal errors, things like that. I don't put points on this one. I got to put points on the last one, but none have B blood. So the first didn't have B blood. So what's the probability of not having B blood? It's going to be 1 minus 0.107. Because this is the complement of having B blood. Does that make sense? The probability of not having B blood is 0.893 because not having B blood is complement of having B blood. Either you have B blood, 0.107 decimal, or you don't have B blood. So we have to take this probability right here, the probability of none have B blood. So the first didn't have it and the second didn't have it. And that's 1 minus 0.893 to the 4th power, because the first did not have B blood and the second didn't have B blood and third. And we take this and we multiply 3, 4, and then we subtract from 1 for the complement. We should be good. Cross your fingers. This has been a wild ride. 100%. Woo! Man, we'll throw an extra 100 right there. Really tough question. Probably one of the toughest ones on here. I've definitely made math errors doing this before, but you need to write the sentences or get practice writing your sentences. If you can ace this problem and understand how to do each step, you understand this chapter really well. It starts out with a little simpler stuff, doing the addition rule and the complement rule, and goes down to much more complex multiplication rule stuff. So you start off with a table using the complement rule, addition rule, and then go down into multiplication rule down there. So really good question. Sometimes I'm mean to MyPearson, but that is a top tier question. Like that is you know how to do it, you really know. I don't like that question. I'll be mean to MyPearson now. Let's do the bowler one, and then we might do data analytics. Really good. Thank you everyone for being here, because these are tough questions. And we're trying to make sure we know how to do them. We'll do a quick one right here. Suppose that 39% of families live in a certain country and 20% own laptops. Can you use the addition rule right here? Just thinking really quickly on this, and a lot of times we put things like this on the test. Why can you not use the addition rule right here? Because it's like, can we add together? Bingo, they're not disjoint, because you could own both. Because if they have overlap, you can't use the addition rule. Great job, Savannah. Nervous kicker. I think someone said nervous kicker. Let's try to do nervous kicker and maybe bowler. Nervous kicker. I think that one was said. Nervous kicker. Thank you, everyone practicing nervous kicker. That last one took a while. It is very, very mathy. A nervous kicker. I should have made it bigger text. Nervous kicker usually makes about 79% of their field goal attempt. If they make the first one, his success rate is 90%. What is the probability that he makes his first 2 kicks? Well, so if like probability, here's the thing, it'd be the probability of making the first and the probability of making the second. And this is a contingent probability right here. So it's literally telling you that all you have to do is say, if he makes his first, he's more likely to make his second, because he's kind of like beat his nerves, I guess. And then you go right there and you solve it. Because it changes the probability. So they're not independent, but because it told you the second probability, it's like his probability is 79%, but he actually gets better if he makes one. And so you do that, and there's the answer. You just multiply them together, and that should be it. There it is. Because it just said probability the first one's made is this, and then the probability changes, which that's meaning that it is dependent. When you say, well, then why can I multiply them? Well, it's saying that this on this next time it is this probability, so it is set then, and you wouldn't keep 0.79 because that would violate the rule of independent right there. I've got a lot of room above me now. Okay, so that was a quick one. Multiply them, but then a lot of people just multiply them, and this is the same theory. So we'll do this one really quick here too. Bowler and high cholesterol. Yeah, let's do bowler. I'm gonna try to do data analytics. Try to squeeze that in this video. I started a tiny bit late, so it's my fault. We'll do this one really quick because it's the same concept. Sure, I usually do a much longer. Sure, watch this. I'll do it really quick. 26% chance of being late to class. If he leaves class late, there's an 18% chance he'll miss the train. What is probability he gets out of class late and misses the train? And means multiply. So it's telling you just multiply them. What's the probability of this and this happening? And there you go. The and means multiply, raise that because it's high. There we go. There is Savannah on fire. Yep, because we can multiply them. It is a contingent probability because it's saying here is the probability afterwards if he is late. If you look at other versions, I've written out a full table of that. But thank you, everyone. Bowler and high cholesterol. Let's do bowler. Bowler's a little bit longer. It does like perfect game and stuff. I don't like those questions. We don't phrase it that way on the test. That one's an easy one. That one's an easy one too. Where's the bowler? The long run frequency, law of large numbers. Probability of event will be observed in the long run frequency. Easier. Okay, we're in the easy stuff. We've done a lot of the toughest ones. Here we are, bowler. We got the bowler one. Let's do the bowler. I think we can do really well at this. We've been speeding up how fast we've been doing it. We've been doing longer, bigger problems. So the very first thing we do is we write down our what? Do not forget this, and please do it each time as I take the notes right here. You know it, you love it. Tell me this time, what are we going to do to start? I want to get you in the practice of this when you get to a test question. That way you can see it. You know right there, Savannah getting some points for us. You write the notation because then you can see it and you know what you're solving. So you always want to write it out and try to do your sentences and write the notation. Certain bowler makes a strike 70% of the time. So immediately when you're given something like this, you want to write probability of an event, and the event is strike and then no strike. So the probability of a strike is 70% because they're awesome, and the probability of not a strike is 30%. I wish I had those probabilities. But we have here the probability of a strike or not a strike. So the probability of going 2 consecutive frames without a strike. So this would mean when they went bowling, they had what happen? I think you're right. Amy, you're on the right track. On the first frame, they did not get a strike, and on the second frame, they did not get a strike. Problem is, and this problem doesn't get into it, is it's probably dependent a little bit, like they get hot or cold. It should say assume that each throw is independent, and double check your good work right there. It will be 0.09, and there it is right there. And it's probability of not strike times probability of not strike. Good work right there. Easy. Don't worry, I'll make math errors. Here it is right here, Skylar. It's probability of not strike times probability of not strike being 30%. So the probability of the first is not a strike and the second is not a strike via the rule of, via the multiplication rule right here, assuming each one is independent, which is a lofty assumption for this. So here's the multiplication rule right here, saying the first is not a strike and the second is not a strike. And we multiply 0.3 times 0.3. Does that make sense? Let me know if you have questions. And Skylar, 100 points. Thank you for asking and being here. Please keep asking questions, especially if something does. Yep, awesome. Now the next one says the probability of her making her first strike in the second frame. So you have to think what would happen. So what events would need to occur if her first strike is in the second frame? So that's where her strike occurred, and this one did not get a strike. So what would happen here? Either one's fine. It'll accept both, Savannah. Savannah, thank you for asking. Either one is fine. It'll accept both answers. It'll delete the zeros. If it doesn't, let me know. So if you got your first strike in your second frame, it would be what? What would have to occur? Like watch. Close, Amy. Well, you're on the right track. So when they went bowling, Savannah has it. Savannah has the answer. So it would be the probability of not getting a strike because the first frame you did not get a strike, and then probability of getting a strike. So that would what would have to occur. You'd have to not get a strike and then get a strike. And notice how I'm saying and. So in your first frame you did not get a strike, and then in your second frame you did get a strike. So you would multiply the two probabilities of point, and I'll write them above it, or you'd multiply the two probabilities of not strike 0.3 times 0.7 right there, 0.3 times 0.7. So the probability of not strike times the probability of strike, because the first was not a strike and the second was, yep, great work. And that'll be 0.21 right there. Good work, Savannah. I feel like people are starting to get it. Well, it says to the nearest thousands. Oh yeah, so it's just in case you have more decimals. The probability of having at least one strike in the first two frames. Now we got to write our sentence. When you see at least one, practice writing your sentence. So she's either going to have at least one strike or what? And Savannah might have it. Actually, Savannah's already done it. Savannah. And I'll solve it here since Savannah's already solved the problem. Savannah, that is correct. I did it in my head while you were doing that. You'll either have at least one strike or no strikes. Now, you know what's interesting is we already figured out the probability of no strikes. No strikes in the first two frames was the first problem we did up here, which is the probability of no strikes in the first two frames, or it says two consecutive frames without a strike, so that could be the first two frames. Your problem might be different with the frames, but the probability of no strikes in two frames is right here. So all we do is do 1 minus no strikes first two, and we do that equals at least one strike. Because either you have no strikes or at least one strike. Is it starting to make more sense, Savannah, I hope? And then you just plug in your numbers, and you plug in the number 1 minus 0.30 to the second power, and that is going to equal to 0.09, which when minus from 1 is 0.91. So that's got it right there. Good problem. Perfect game requires, I believe, 12 frames. They luckily tell you that. So you'd have to get a strike. What would you have to do to get a perfect game? This one's kind of neat. And this is why the thousands is going to matter. So even if you're a 70% strike thrower, so what is the probability of a perfect, or how would you find the probability of a perfect game? You'd have to get a strike and do what? You'd have to get a strike and what? I think I'm going to do data analytics next. You'd have to do what? Every game is 12 strikes. What would you have to do? How would you get a perfect game? So considering we have... So Amy, solve that out and tell me what's odd about that. And Savannah, I think, has it. So notice here, and that's a very... And Savannah, and I want to say this. This is the mistake everyone makes, is they multiply it by 12. But then be like, wait a minute. Once you do this, I want to point it out again. If you do this, then what do you immediately notice? You should notice something and be like, that violates a rule of probability, right? So that's where we say I did something wrong. So it would be the first is a, bam, Savannah got right there. The first is a strike, and the second is a strike, and the third is a strike. And if you write this out, you'd write probability of strike times probability of strike times probability of strike times probability of strike, and you would do it a bunch of times till you do it the 12 times in a row. And that would be 0.70 times 0.70 10 times in a row, which is 0.70 to the 12th power. So that's got it right there, and I think Savannah's done it. So Savannah, I'm gonna go on a limb here. I think Savannah's got it. Did it want to crazy decimal places? Did it? The 10,000s, 10, 100, thousands. That's gonna be right there. So I think it's this. Oh no, did it really want that? Want that next digit? Oh, I might have taken your answer, Savannah. Okay, 0.70, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, it's not that small. You might have had different. Thank you so much, Savannah, right there. There we go. What? Does it want the next 10, 100, thousands? Oh, wait. Wait, what? Okay, wait. Did I do a wrong? Oh, no worries. I don't care. 100 points. We had to get one wrong today, right? Let's get one wrong. One wrong is fun. Bunch wrong is sad. 10, 100, thousands. This is the thousands right here. There we go. There we go. If you had gotten this wrong on MyPearson because of the decimals, we give it back to you. Amy, 100 points, rounding it correctly right there with the thousands. I thought I said 10,000s for a moment. I don't know where I got that. But yeah, good work. We just throw out tons of points. We're here to have some fun and do some problems. If you're stuck on any of the other problems, let me know. We're going to do the data analytics to finish off right here. A lot of good questions were completed here with the multiplication rule, the addition rule, the complement, the set of all probabilities equals up to 1, the probabilities are contained between 0 and 1. So a lot of rules right here. Getting questions wrong because of decimals. Yeah, and if you do that, email me and be like, hey, Brian, I got this wrong, and I will fix it. I do not want you to have an error like I had and lose points because of it. That's ridiculous. So data analytics for regression. Okay, let's go check out that data analytics. Got it pulled up over here. Where did data analytics go? Had it pulled up. Here we go. Data analytics. Data analytics. So this data analytics is over regression. When it comes to regression, you are going to have a few key tasks here at the bottom. And look, once again, always use your rubric to make sure you're answering the questions where it says like your write-up is accurate with complete sentences in paragraph format, so you can't use bullet points. Thank you, Aaron, right there. Throw you 100 points. Make sure to do this right here and to have the complete sentences, like report if the linear regression relationship between price and carrot is statistically significant. Define, include the value from the output you see to support your conclusion. Report the value of the R-squared and its proper interpretation. Report the slope, B1, and its proper interpretation. Report the intercept, B0, and its proper interpretation. Provide all the conditions, QQ straight enough, no outliers, plot doesn't thicken. Those are the 4 conditions right there. The appropriate analysis were performed and correct screenshots were taken, random sample, and your stuff at the top. So the first thing I would do if I was making my assignment is I'd go over here to a new Word document, and I would drop in this. You can just basically, you could pretty it up a little bit. You could be like, you know, I'll make this little party right here. And you could go and put it over here on the side, on the right. There you go. There you go. Nice and neat. My name is Brian. What's your last name? Stevens. Your UTK email address. Just fill it in right here. B. Stevens. UTK.edu. My instructor is Brian. You probably do that. Your section, online, stat 201. That's fine right there. Section 4 or something like that we are. Make sure, probably, it's gonna be very important you put your section if your instructor has multiple sections. I would highly suggest that section, put instructor Brian, I don't know which class you're in if you put that. Where can I find the Mars problem? Make sure to do this search on the channel, and using the search, watch this, I'll show you a cool feature. Where is it? Oh my gosh, I can't find the mouse. If you ever are looking for something on the channel, and you go here to the stat 201, and you type in Mars, and I bet you this has got it. And the search feature, boom, there we go. We got the Mars candy bar. And here it is right here for you, Skylar. The link is in the chat. Click the timestamps below. 1,500 views. Oh my gosh. I don't think we're pulling views like that this semester. But see, look at that better lighting right there. Better lighting. Just happy that our lighting looks better. You're welcome, yeah. And the search feature, a lot of people don't know it exists, but you can search for pretty much any video like Red Cross. So you can do Red Cross, and you could probably find one of the videos where I go through the Red Cross things, because that looks about the same time frame. So there's the American Red Cross problem, bowler problem, after rolling doubles. You'll see a lot of associated things in there. So yeah, that's good stuff. So check it out. Thank you, Skylar, for asking. So with this right here, we've got our information in here for how to basically start the document and get those points. Make sure to get those points. And then let's go back and look what we need to do. Now we're doing regressions, so I'm going to do a different regression. I'm going to load up some jump right here. Make sure to have jump on your computer, jump 15, 16, 17, maybe there's 18 now. Rock knows.
It doesn't matter.
Doesn't matter what version of jump you're using as long as you're using jump. So of course, Brian being Brian, I'm going to analyze Pokemon data. Now you're not going to analyze Pokemon data. You're going to analyze a car, I believe, with price. Let's double check what you're analyzing. You are analyzing the mileage of a car, predicting price. Now we say predictor here, but I would preferably say the explanatory variable. The response, usually we call the Y variable the response variable of interest. So make sure you are predicting price. Like people usually care about the price of a car. I didn't say, well, I care about mileage, but the mileage explains the price. It predicts price. Like this car has high mileage, I predict it will have a lower price. So the explanatory variable, the X, or the predictor, is the mileage, where the predicted, the response, is the price. Understanding words like this is key, that when we say the explanatory, explanatory, also knowing that it's the predictor, it does the predicting. Okay, enough about that. I'm going to do a different type thing, but you need to make sure you take a random sample of 300 plus the last two of your UTID. So you go here to table. Under table, go to subset. We'll pause right here. Table subset. Under table subset, you will then go and type 300 plus the last two of your UTID under random sample size. With this, you will click OK. Boop. Now you have your random sample. You do not need to take a screenshot of this because we'll be able to see in your output if you took a random sample of 313 or whatever you need to take. Only take 313 if it is your random sample, not like I'm doing here. That is just my random ID number. So with this in mind, when you are doing regression, one of the first conditions is QQ. Now it's said in the notes as two quantitative variables, but I call it QQ because I'm saying quantitative quantitative. It's an abbreviation for two quantitative variables. So to do regression, we go to Analyze, Fit Y by X. Analyze Fit Y by X is the bivariate platform allowing us to look at bivariate relationships. So under this, we are going to select the two quantitative variables we want, make sure to choose the ones for your problem, where I'm going to analyze the attack power of a Pokemon is of interest to me. So that's the Y variable of interest. And I want to know if it's hit points explain attack power. So I have explanatory variable hit points, or predictor, and the Y variable of interest, the response, is attack. Go ahead and click OK, and you will see your scatter plot. Mostly good. Mostly good. Yours might have different conditions, or it will have the same conditions, but maybe different problems. So to make the regression in the scatter plot, we need to go here to the red arrow. The red arrow gives you options, and under the options, we're going to go to Fit Line to Data. We fit the line to the data, boop, and now we get the red line in the data. There's the regression line, and with the regression line now fit to the data, we are going to add in also, and I think you can see it, plot residuals. Good, it's right there. Plot residuals. Make sure to plot your residuals. Boop. Now, when you're doing this, you need to make sure to get the output you need. We don't need the analysis of variance section. It's interesting. We'll talk about it in other classes if you like. Here is the output we need for the regression, and let's go ahead and screenshot it. Make sure to take a clear screenshot. Only get the information needed. If you do get too much, like you don't want this, go over and after putting it into Word, go here. This is too much. Brian made an error. So if you screenshot it correctly, good. If you get too much, go to Picture, then go to Crop, and drag in the little black edge right there. Make it nice and perfect. Even a little bit down there too much. There we go. We're gonna shrink it down a little bit to make it not so big, and that's a good size output, good format for the page, easy enough to read. You can center it, even do a little border. This is not required. I wouldn't use that. I'd do a little nice border around it like that or something. Nice, clear screenshot, good to see. Don't block any of the output with a border or anything like that. Don't obscure it. So that is the regression output. We also need the residual plot. I preferably use the top residual plot right here. We'll talk more about it in a second, but we're gonna do the same task. Remember, take a good screenshot. You don't need the diagnostic portion, but you do need residual. And if you do get too much, don't get too little. Can't fix that. If you do get too much on your screenshot, after pasting it in with Control V or copy paste, I'm using Command V or Control V to quickly paste right there. Go to picture format, crop the picture. This would probably be acceptable, but it never hurts to take and make it nice and perfect right there with an extra second of work. And then go to the picture, and under the picture, make sure you have the picture format selected. You can add in a little border. There's other ones I like too, like that's all right. And it's not blocking the output, and maybe low on the bottom. So we'll use the same. We'll go for the consistency. Now, what I want to point out right here is notice these 4 points right here. They're the same 4 points. I'm going to highlight them for you. A residual plot is made by making the regression line flat. So because this point right here is above the regression line, it's above in the residual plot. This right here are 3 points below the regression line, and there's the 3 points right there. You take your line, you make it flat, and you set the line equal to 0, because anything on the line would have a residual of 0. Things above the line, the actual being more than the predicted, have a positive residual. Things below the line have a negative residual, which are indicated right here by the positive and negative numbers. So a positive residual means the actual, the dot, is higher than the predicted line, which the line makes predictions according to the regression model. And a negative residual means the actual, the dot, and I'm talking about, if you hear me say dots, I'm talking about these dots right there. I'm just gonna go crazy. The dots below the line, the actual is lower than the predicted, is a negative residual. Definitely on the test and on Canvas content. So with this in mind, we understand what we're seeing. It's called a diagnostic plot. You might have seen that in JUMP, because it helps us diagnose issues. It's like you could go to the doctor and they could just take a picture of your hip, or they could take a radiograph. The radiograph is going to be the diagnostic picture. So this is like the picture of your hip, and this is the radiograph. It's getting a more diagnostic view, allowing us to diagnose issues. Specifically, mine does look to have a little bit of thickening. I would say there is the presence of some thickening throughout the plot. Another test question, a residual plot is a great way to check the fourth condition. Plot does not thicken, the way I like to say it. And you don't want this plot to get thicker or thinner. It does have the same sort of issue over here because it's the same plot. It's just a little easier to see in the residual plot. So let's write our conditions. I'm not going to fill out everything properly, but I want to show you a good format for this. So with this, if we're writing out our conditions, the 4 conditions are going to be 2 quantitative variables, often abbreviated by me to be QQ. We're going to write here either it's met or not met. And frankly, this has to be met, so I'll give you that one. And I would state that my variables, whatever, are both quantitative. So I don't want to say everything because I want everyone to write exactly what I write, so I'm kind of giving you hints. Straight enough. And you need to figure out if it's met or not met. A lot of people are probably going to have this format now. And I'm going to tell you how to explain these, but not give you exact wording. I want you to kind of think through it a little bit. And no outliers. You don't want there to be outliers. Try writing a full sentence in your own words. Remember, don't use other people's words. Use all my words. Use your words. And plot does not thicken. I like to say plot does not thicken. If a grader takes you off, how do I to do the M&M? If you're stuck on how to do the M&M, we don't have time today for it. We might do it at the end of class tomorrow. If you're stuck on the M&M problem, check this out. There's past Brian right there. For the M&M, go over here on the channel and type in M&M and October 25th. Oh my gosh, here we go. Here is a direct link with medium hair length Brian on the M&M problem. You're welcome, Savannah, yeah. So remember, and this is a great option, I always like to point this out to people, that under the Stats 1 channel, you can usually type a keyword in here, like Red Cross, and if you do this, you will see an office hours pop up since all the videos get labeled, and you can usually find one of the videos where I go over the question, and then you can kind of skip through it since it's pre-recorded. I'm thinking about it, Kyle. I'm trying to figure out, I'm gonna look at the schedule today and figure out where to go with that. That's what I'm thinking through. That's in my brain, because I kind of wanted to do 12 yesterday, but I was like, we kind of need to review. We got a really good knowledge of chapter 10 yesterday. So that's where I'm like, what do I do with our time? What do I do with it? How do I optimize time? I'm not in like rush mode, but I want to make sure we do things properly, thoroughly, and understand the concept. So I'm going to look into this. So 2 quantitative variables met, straight enough. And how to check straight enough is, does the line go through the center of the data? An example of a plot that looks straight enough would be if you have a line and it's going through the center of the data. This is good. And if it has a little bend, like the points put a little bend, it's still good. That's probably good enough. Straight enough. The example of not straight enough is when you have a line and the points curve around it. So this would be your no, it is not straight enough because write your reasons, like it's explained, put the things met or not met. And then write a full sentence. Be a full sentence. Don't look at what anyone else writes. Don't say verbatim what I write. Think about how you're explaining about the points and about the line and the things. So do that right there, because everyone think about how that line, either the line is a straight enough relationship or it's not, because the line is either a good way to model the data or not. So no outliers. This one's one of the easiest ones. And I would even mention your outliers. So if there's no outliers, you're going to see data that looks like this. And if there is an outlier, at least one, you're going to see the outlier. So this is the it is not met world. This is the is met world, where you're trying to talk about the presence of outliers, which would drastically impact the model. And talk about them, mention them, say why this is bad. So put if it's met or not met. Plot doesn't thicken. Plot doesn't thicken means that it stays relatively the same thickness throughout the plot. And so when you see relatively the same thickness, you would have right here a plot that has about the same thickness throughout. Notice how the scatter of the points, the vertical scatter up and down across the line, is about the same, where in the lower one I'm about to draw right here, which is a negative plot, the plus or negative,
it doesn't matter.
Doesn't matter. And it could get thicker in one spot, like it gets really thick there and then it goes back. That's not good. You don't want it, you want it to stay the same thickness. The predictive power of the model should stay the same throughout the model. I think we said that one a lot during class. The predictive power of the model should stay the same, which is plot doesn't thicken. So this is the problem right here. That's plot doesn't, that is plot thickening. That's a bad thing. So you would, in this instance, on the bottom one, you would say at the middle of the plot, there's a huge thickening area, and then talk someone through it and explain why it's bad, that the predictive power of the model. No, JT, oh, well, some are still here. Give a hello if you're still here. Maybe it says 2 viewers, JT, 100 points. Thank you for being here, JT. A lot of people use this in the future too, hence why I put all the timestamps in. And so I did this at the end because we had a lot of people here going through the problems, and you never know. You know what today is? We didn't even say what today is. Crash knows. We didn't even say it. Oh my gosh. It's Wacky Wednesdays. We didn't even tell anybody. And I would also use the residual plot down here to talk about plot thickening. And clearly at the middle of the plot there looks to be an issue with the thickening. So you can see the thickening in here, where towards the middle of the plot decreases in predictive power, which is not what we want. We want it to stay about equal strength throughout. We want it to be about equal strength. We're not erasing that apparently. So with this, we now need to interpret some quantities. And once again, I beg this of you, I beg you, please look at the rubric. The rubric walks you through exactly what you need to do. I took a random sample, I got the appropriate screenshots, I provided the conditions and talked about why they were met, go into full detail, write full sentences, and now we need to do the intercept, the slope, and the R-squared, and the statistical significance. So let's start out with the intercept here. Intercept. When x is equal to 0, we expect y to equal b0 on average. Slope. For each 1 unit increase in x, we expect y to increase/decrease by b1 on average. R-squared. And you need to write full sentences right here. These are just notes for you to use. And this is on the test once again, where we do have you write full sentences. So know how to write these. Blank % of the variation in y is explained by the variation in x. Blank % of the variation in y is explained by the variation in x. So here's what you can do with these. Once again, put these on note cards so you can practice and remember them. But if you look up here at the top, you'll notice horsepower is x. So everywhere you see x, that's where horsepower would go. Here we have attack power of a Pokemon is y. That's where y would go. The r squared is the r squared, which we do multiply by 100. So the r squared always gets multiplied by 100. There we go. And the b0 is the intercept, which the value of the intercept is here. It's also in the regression equation. The regression equation is y hat equals b0 plus b1x. And thus the b0 is there. And where we see b0, that's where we plug in that value. And last but not least, we have the value of the slope, which the slope value is right here. And that's the slope value also right there. And it is right there. So if you kind of notice where a lot of things are, that's the x, and there's the value of x. We're showing where everything in the output is located, so that way you can find it and understand we're predicting attack from the equation, the intercept plus the slope times the x variable. And so when you read this off, you just plug in your words. You would say when a Pokemon's HP, not horsepower, hit points, when a Pokemon's hit points is equal to 0, and we'll add in one thing here, is this logical? Is it logical? And so what do I mean by that? Well, when I say when a Pokemon's hit points is equal to 0, we expect its attack power to equal 28.43 on average. And 28.43 is the value. You can still see the color coding right there. 28.43 is the value there. So the problem is you can't have a hit points equal to 0. That Pokemon would not exist. It has no hit points. It's not when the Pokemon faints even, it's just its base hit points. So that is a problem. So that is an illogical intercept. This does not make sense. It's an extrapolation of the model 2 because there are no Pokemon at 0. There are close to 0. Who knows what that is? Maybe a Shuckle or something? I don't know. But it's a Pidgey. It's always a Pidgey. So with that, we cannot say that this is a logical intercept. It doesn't really make sense to interpret it due to extrapolation going beyond the x bounds of the model. For each 1 unit increase in a Pokemon's hit points, we expect its attack power. I'll try to get on the screen at the same time. There we go. We expect its attack power to, and notice it's positive right here, to increase by 0.732 on average. So for each 1 unit increase for each additional hit point, we expect a Pokemon's attack power to increase by 0.732 on average right there. And then the r squared, here we are. Basically 30. I can round up to 30%. 30% of the variation in a Pokemon's attack power is explained by the variation in its hit points. There we go. There's the interpretations. Make sure to write yours out in full sentences. Include them in probably it says in paragraph format. I cannot state this enough. Look at the rubric. It says right here, paragraph format. I am doing notes for you. Paragraph format. Please look at the rubric. I always want you to know that. And we're just one step away right here because when we look at the significance of a model, and I wish this turned out a little different in the output. Let me try to do one that might turn out different. Maybe, please. Yes, good. Okay. I changed my model for a reason because I wanted to point this out, that this p-value, although we're not using it, is the significance of the model. You see this 0.00002? The analysis of variance is the reduction in the sums of squared error. We don't need to talk about that. But that p-value on the analysis of variance is the p-value for your model because the significance of your model is the significance of the x variable. So I purposely put in one where these two are different to point out that it's not the intercept. The intercept's just an arbitrary point over here. If there's a 0 slope, then your model will not be significant. To demonstrate this, I can just go right here and do like 100, 102, 100, 102. I think this should work. I'm thinking if this pattern will make what I want. It's not quite a box. I should have done a box. No, need to do a box. That'll do a box, I believe. Just thinking through logically. That is right. There we go. Now, if you look at this right here, this is not significant because it's flat. And the p-value here for the slope, which is the x variable down here, is as high as it gets because it's perfectly flat. The slope is 0, which is the least significant relationship. But the intercept is up there at 100. And although that's not significant, I kind of wish it was. I guess lack of data. So we could make that even further away. I want to show you the intercept being significant.
It doesn't matter.
Rock knows. Okay, now we should get a significant intercept. All a significant intercept means is your intercept is very far away from 0, which doesn't matter. Oh, it's still not significant. Huh. Look at that, standard error is calculated on. Oh, really? Huh. Standard error didn't change. So the intercept is still not significant. I know how to make it significant. Increase sample size decreases standard error. There we go. Slope will remain the same though, because it's just repeat data. Now it should be significant. Yep. Increase sample size, decrease standard error. So with this right here, this is not a significant model. And why? The whole reason I've been doing this here is to show you the slope is not significant. The model is not significant. This is more of a 320 output when we do analysis of variance, but the slope being not significant is what we point to in stat 201, and the slope is the p-value of the, or the significance of the slope is the p-value of the x variable. So my model over here originally, the very first one, is significant due to the p-value of the slope being below 0.05. Statistical significance means a p-value is below 0.05, and it usually will have a star on it, and output, jump puts a star on it. And yes, that is a statistically significant slope, which means the XY relationship is unlikely by random chance. And so, well, that's got it. And it's not the p-value of the intercept. Hence why I did this one where you can tell that this is the significance of the model, which is the significance of the slope. And then I did one where it's not significant, but the line's completely flat. And a flat line is no relationship because as x or as you go up to upper values of x or lower values, there is no change. There is no relationship. It's just randomness. And with that, bye for now, everyone. Bye.